So this video is going to be all about how scopes are created, how we create new scopes. How do we protect our variables and make them so that we know at all points who is controlling them and where they're accessible from, and how to prevent cluttering up our global window object. So let's go ahead and get started. I'm going to comment out this example here, copy the header, and So yeah, let's go ahead and write example 4. So how do we create scopes? Well, we've already seen examples of creating scopes, and you might already be familiar with this. But it's okay, it's a short example. I'm going to go ahead and say var a equals 42, var b equals 57. I don't know why those numbers keep... Well, 42 is pretty obvious why that is in the top of my head, but I don't know about the 57. Example 4, and then I'm going to say var a equals 10, var b equals 10. So we could also have written this as var a equals 10, comma b equals 10. Notice the comma there. The comma makes it so that we get two var statements with only using one var keyword. And I can go ahead and console log out a followed by b, or maybe a equals a and b equals b. So now I can go ahead and run example 4, and then I can console log out. Let's go ahead and grab this guy here, and we can see the output. So think for a second what the output will be. It's already on the screen. We see that the output is what we expected. And the reason that is because we use the var keyword to create local variables that weren't attached to the global scope. Now, what's interesting about this is these var keywords up here did indeed attach to the global scope. The var keyword, basically what it does is it says whatever scope we're currently in, go ahead and create and attach this variable to that chunk of memory. Right? So because this code is executing out in the global scope, A and B, these two A and B's are in the global scope. And I can prove that by coming over here to my console and saying window.a and window.b. So these two are global variables, but these two variables are inherently different. So these two variables are instead attached to this function. So we see that in JavaScript, we create scopes by creating functions. Functions allow us to encapsulate data. They are the hunks of memory where our data lives. And it always has to be incredibly important that while you write JavaScript, you always know which function or which scope your variable is attached to. And in this section, we're going to be describing just that, all the behaviors, some weird, some not so weird, of the rules of how it is determined which function, which variable is attached to. So let's go ahead and write another example, and this one's going to be it's going to be a little bit more complicated, but I'm actually going to be creating two functions, one inside of another, which I'm sure you've seen examples of before. So let's go ahead and comment out example 4. Again, the difference between example 4 and the earlier example was that we used var in both variables, allowing us to create two local variables to this function, so that those are indeed attached. So let's go ahead and write example 5. And for this, I'm going to do var a equals 10. I keep on reusing the var a for some reason, which is primarily why I'm commenting out all these previous examples so it doesn't conflict. And I'm going to write a function. JavaScript, you write a lot of functions. And then in this, I'm going to do var a equals 20. Then I'm going to do function inner. So I'm creating a function within a function. It's very JavaScript-y thing to do. I'm going to say var a equals 30. And then I'm going to say console log inner colon plus a. And then I'm going to invoke inner down here. Then I'm going to say console log outer plus a. And then I'm going to invoke example 5 in the global scope, and then I'm going to say console log global a. So I'm not going to hit Control S just yet. I want you guys to think just for a second of what do you think the output will be. How all these variables are interacting with each other. Now, don't worry if you're having a difficult time visualizing this. I have slides here coming up that will demonstrate what is going on with this example, why this example is important. If this looks trivial, bear with me for a moment. So, what do you think the output's going to be? Let's hit Control S and find out. Inner is 30, outer is 20, global is 10. So that's kind of the behavior that we would expect, and that's because we're writing well-formed JavaScript here. We're declaring all of our local variables with a var keyword. Remember, that var keyword anchors that variable to its outermost, or not outermost, its closest function. So this var keyword anchors this variable to the inner scope, whereas this var anchors this a variable to the example 5 scope. And this var anchors this variable to the global scope. Of course, there would be no difference between, in this case, me not using a var keyword and me using a var keyword. They're basically the same because we are always acting on the global scope. So think about that. Now let's go ahead and remove this var keyword. And what do you think the output's going to be now? So let's go ahead and hit Control S. And now you'll see that inner and outer are both 30. So now we see that this binding. And when I talk about variables, I often will say the word binding. A variable is, think about it as a name, a named thing, a named piece of memory, and that name has to be bound to something. And where it's bound to determines where in memory that variable is going to modify. So by taking off that var keyword, I am now kind of detaching this a binding from the inner function, and it is now manipulating the a variable in the outer function. So when I call inner, we get 30 after we call inner. If I were to call it before, obviously we would get 20 first on outer, then 30 on inner, then 30 on outer, and then still 10 on global. So let's visualize this. I'm gonna pop open some slides here. So this is just a really basic little thing. I just screenshotted the code and brought it over here. So we have our with var variable or example and our without. And the exercise that I want you guys to do when reading this code and reading your own code and writing your own code is always being aware of your variable bindings and where exactly that's being bound to. So in the left example, we have with var, we have our example 5 and all that stuff. Let me go ahead and actually visualize all the scopes that are in play in this example. So as you see, we have 3 scopes. We have the global scope, because that's outside of a function, it's global, it's being executed against the window object. We have our example 5 scope. So notice how we've created a new scope just by creating a function variable. We're actually creating a new scope not by any means of execution here, but by means of simply declaring the var keyword inside of a function, and that binds that variable to this function. And then we have our inner scope, which the same thing's going on. So as you see, this a is referencing this a variable and nothing else. That's being overridden. Whereas this a is only referencing this a and not the global a, and that's what's being written down here on the outer. And then the global, that a is being referenced by that a. So those are our 3 scopes. So let's see how this differs from our without var. So without var, we notice that there's really just one big difference here. We are now referencing the a from the parent scope, and that's because when you have a variable, when you reference a variable known as a right-hand side reference, or both right-hand and left-hand actually, it's going to walk up the chain of the scope chain. And it does this not dynamically, and we have a video about static versus dynamic scoping coming up in a couple videos, but it does this based off of where the code appears statically within our text file. And so the JavaScript compiler takes a look at this, and when we say a equals 30, it has to figure out where in memory, where in the scope chain is it going to be referencing. And it notices that there are no variables declared in inner called a. So what it's going to do is it's going to walk up the scope chain. And again, the scope chain is determined purely by where the code physically exists in the text file. So the compiler will see this a equals 30, notice that, hey, there is no variable called a in the inner scope. So walk up. And when it walks up, it now sees that there is a variable named a in this scope, so it attaches itself to that variable. So whenever I reference the a variable within the inner scope, we are referencing the a in the parent scope. And you can see that visually represented here because of this green highlight, whereas over here it was a blue highlight. So what we've done here is we've been creating scopes this whole time. But the var keyword is so incredibly important because, again, what it does is it says, hey, JavaScript compiler, this scope has this particular variable, and this particular variable, I want it to allocate memory when this function is called. And so when the function is called, the memory gets allocated for this variable. And then when the runtime starts to go through and starts executing our code, every time it sees a variable reference, it needs to figure out which allocated piece of memory are we going to access. And we see a conflict here where we probably in our inner function didn't want to modify our outer function's a variable. So again, you can always figure out what scope which variable lives on just by reading the file, just by reading the code itself, and by noticing where the var keywords are located. And this comes into play when we will discuss closures later, and because closures are can be confusing, and they're very interesting, and it's very important to dispel any potential confusion that you might have with them, since they're incredibly powerful. Anyway, so let's do a brief discussion about function parameters. This is just going to be a really simple example here, so I'll go ahead and comment this out, and let's do example 6. Blah blah blah. All right. So this is another important thing that you have to very much internalize. So I'll do function example 6 a equals 20 console log a, and then I'll say actually I'll do this up here. I'll say var a equals 30, and then down here I'll say example 5, and then I don't know, we'll pass an a, I guess, and then we'll do console log a. I can actually make this a little bit better. I'll do global followed by a, and then right here I'll do example 5 a. So what do you think the output of this script is going to be? Think about it. So we see that we don't have the var keyword anywhere. What do you think? What do you think is going to happen? So let's go ahead and hit Control S. And as you'll notice, we get example 5 is 20, which is pretty much what we expected. Example 5 is invoked first before the second console log. Then when example 5 runs, it sets a to 20, and then runs prints out example 5a, which is 20. But then says global 30. All right? And so what's going on here is you can, for parameters that are passed into functions, you can always imagine them being declared with the var keyword. Now, there is no var keyword, but think of them as local variables. They, for all intents and purposes, they are already local variables. So when I have a parameter right here, and Visual Studio Code is kind of cheating right here. Notice how my keyboard cursor is on this A, and it's only highlighting this A, but not the outer A. That's proof that the parameter is acting as a local variable. So when you want to know which variables are local to which function, you have two places to look. A, where are the var keywords located? And B, what parameters does the function accept? Because if I took off this parameter here, and then I came back over here and highlighted this A, notice how we're now working against the global A. And if I refresh, now we get 2020. But if I put this A back in here, we are now overwriting example 5 scope and adding A to its scope, to its block of memory that it has. Therefore, this A no longer references the outer variable. Now, let's talk about something else, something that this does confuse a lot of people, and at first anyway, but hopefully I'll be making it clear why the behavior is like this. Let's go ahead and write function example 7, and I'm going to say for var I equals 0, I smaller than 10, I plus plus, just a simple loop. I'm going to say if I is greater than 5, I'll do var test equals I times 10. And then down here, I'm going to say console log I is plus I, comma, test is test. And I'll go ahead and make that a lowercase. And then I'll simply invoke example 7. Okay, what do you think the output of this program is going to be? Think about it for a second, because this is different behavior than many, many languages. You would actually, in many languages, particularly statically typed languages, compiled languages like C#, you would look at this code and you would actually expect it to be a compiler error. But think about it for a second. I'm going to go ahead and hit Control S. And as you see, I is 10, test is 90. So this is an example of what doesn't create a scope. Statements, block-level statements such as loops and conditionals and switch statements and all that fun stuff do not create scopes. Blocks do not create scopes. In fact, I can create empty blocks for days, do var ble equals 20, and it's funny because that var ble is actually still accessible after I close out of all of those scopes, all of those block level scopes, quote unquote. They're not actually scopes. They would be scopes in other languages, but this is something that troubles a lot of people. And another reason why it does is because reusing variable names even if you have a variable defined in a for loop or an if statement, reusing variable names in JavaScript is a very bad idea. It's a very bad form because the var keyword doesn't attach this variable to the closest block. See, these are just arbitrary empty blocks. It attaches the variable to the closest function. So I can declare this var test equals I times 10, and that creates, a variable that is attached to this function, not to this block, meaning that variable is still accessible from outside of the block. So this is another thing, a common thing that trips people up, and another probably great interview question, I would imagine, for a junior JavaScript developer position. So yeah, I just wanted to point out what doesn't create scopes. So what does create scopes? Functions. What doesn't create scopes? Block level elements such as for loops and if statements. Now, the latest version of JavaScript did introduce a feature that allows you to create block level scoping, and we'll talk about that in a later video. So yeah, so far, just to recap what we've discussed so far, a scope is where your variable lives in memory. It's where your variable is attached to. Functions create scopes. The var keyword or function parameters create variables that are attached to the closest function that's in it. So by just physically walking up this code, we see this var, physically walking up this code, we see the closest function is example 7, meaning that this var is attached to this function, not attached to the global scope. I'm not able to, I can't do console log window.test, for example. You see that it comes back as undefined because this test variable had the var keyword. The var keyword attached it to the chunk of memory that was created when this function got called. So when this function got called, the JavaScript runtime said, let's go ahead and allocate enough memory for this function to execute. And it knows how much memory it needs to execute by counting how many var statements, variable declarations there are inside of that function. And so then it allocates that memory, and that's where these variables live. All right, so with that, in the next video, we're going to be talking about immediately invoked function expressions, or IFEs. And we'll see you guys then.